morning, my YouTube viewers. It's Crystal here. In this video, we're going to cover another parametric test. And this nonparametric test. And in this nonparametric test, we're going to discuss is the Wilcoxon signed rank test. So the Wilcoxon signed rank test is a paired test that compares the medians of two dependent samples. It's often used as a nonparametric alternative to the paired t-test. So what we're going to do is we're going to go over the code of a small program to demonstrate the Wilcoxon signed rank test. So the first thing that we want to do is we want to generate some data. And so our x variable is a vector of numbers being 12, 15, 14, 10, 9, 11, 13, and 16. And the y variable is a vector of numbers being 14, 14, 15, 11, 8, 12, 14, 18. So we're going to take the difference of the two vectors. So d becomes x minus y. So one thing that you can do if you want to see what the difference is, we'll just run this again. I'm running it again and I'm hoping for the best. So we can come down here and we can look and see what so we've got two D's. Let's run two D's up again. So this is the difference. The difference is 2, negative 1, 1, 1, 1, negative 1, 1, 1, 2. So that's the difference between x and y. And then so we're going to run the Wilcoxon signed rank test, which is paired. So test becomes wilcox.test brackets x, comma, y, comma, paired equals true, comma, exact equals false. And then you can run the test. So we come down here. So this is the test. Wilcoxon signed rank test with continuity correction. So data is x, y, v equals 7, p-value is 0.1236. The alternative hypothesis is true location shift is not equal to 0. But the p-value is greater than 0.05, so that means they're going to fail to reject the null hypothesis. So the null hypothesis would be true location shift is equal to 0. But that's just how the test is run. So now we're going to compute the signed ranks. But you see here, we've got the differences here, d becomes y minus x, and you've got the compute the signed ranks is d becomes y minus x. So that's like exactly the same piece of code. So I'm just going to take that out because it's exactly the same piece of code. We got d earlier up in the program. So ABS, that means absolute value of the ranks, becomes rank ABS D, and signed ranks becomes ABS ranks times sign D. And then we're going to plot the data. So POS ranks, that's positive ranks, becomes ABS ranks, brackets D greater than 0, and neg ranks, that's negative values, becomes ABS ranks, brackets D is less than 0. And then so we're going to create a bar plot of the total positive and negative rank sums. So rank sums becomes a vector of sum positive ranks, comma, some negative ranks. So you're going to add up the values of the positive ranks, and you're going to add up the values of the negative ranks. And name rank sums becomes a vector, positive rank sum, comma, negative rank sum. And then we're going to put a bar plot in there. So rank sums, the bar plot brackets rank sums, comma, color equals a vector of forest green and fire brick. Y limit, that's the limit on the y-axis, is a vector of 0 to the max of the rank sums plus 5. Main is your title, is Wilcoxon signed rank test. Next line, positive versus negative rank sums. Y lab is your label on your y-axis, is sum of ranks. We're going to put some more text in there. X equals a vector of 0.7, 1.9, and y equals rank sums plus 1. Labels equals round brackets rank sums rounded to 2, and CEX equals 1.2. We're going to put some more text into the chart. We're going to say paste 0 brackets two-sided p-value equals significant brackets test $ p-value rounded to 3 digits. Side equals 3, line equals 0.5, CEX equals 0.9, and we run the program. And then when you run the program, you see that the positive rank sum is 29 and the negative rank sum is 7, but if you still get a low p-value, you've got a p-value, two-sided p-value of 0.124, so that p-value is still greater than 0.05. So that means that you would fail to reject the null hypothesis in this situation, even though it does look to me like there's a difference, because the positive rank sum is 29 and the negative rank sum is 7. So that concludes this video. The next video is going to be another non-parametric test. So I hope that you decide to watch the next video, and I hope that you got something out of this video, and thank you very much for watching.